Good morning, grade 10 learners. I am Marita Kotze, Senior Education Specialist for Physical Sciences. I hope you can hear me, and very welcome to this session this morning. I'm just going to give us a few minutes so that to give all the attendees access to the webinar. So let us just wait a few minutes. I just want everybody to log in and to see how many attendees are in. Already logged in. All right, you can see there's a hand on the right hand side or at the bottom. You can just raise it so that you can. I just want to see if you can hear me. Okay, thank you very much, guys. Thank you. All right. Okay, let's just give another minute. I'm so excited this morning to talk to everybody. It's been 2 weeks now, more than 2 weeks, that I last speak to you guys. So yes, a very welcome to all of you. Just let us wait a few more minutes. Yeah, so logging in. Logging in. Okay. All right, I think I'm going to start this session now. Can everybody hear me? Thank you very much, guys, for showing me that you can. Hands up. Yes, thank you. Okay. While we're waiting, there are handouts this morning at the bottom of the. You can see there at the bottom in the box. In the handout box, there are question papers again that you can download. Make sure that you download them. Okay, I'm going to start the session now, so everybody is here. All right, guys, I am Marita Kotze. I choose another picture this morning so that you can see that why are you doing chemistry? I know a lot of grade 10 learners asking me that. Why are you going to do this? It's very difficult, but I'm here to help you, and please feel free. As you can see here, Junior wants to be an agricultural chemist. So why did he decide to do that? Because the label on the bread, on the loaf of bread, inspired him. Guys, I really want to encourage you again to look around, to see chemistry in everything that you're doing now, the oxygen that you inhale each day. Yes, so make sure that you, in this journey of physics and chemistry, that you do love this. It's really knowing more about physics and chemistry. It's really, for me, it's my passion. So yeah, let us just, before we start this webinar, cover some of the basics this morning. If you're struggling to hear me, make sure your audio is on and your speaker volume is turned up. I know that I do have everything here on, so I hope you can hear me this morning. You will automatically be muted when you're joining this session, so I'm not going to be able to hear you. But you can ask questions, not during this session. I will handle your questions after the webinar. It's better for me just to then answer all the questions. So make sure that you write your questions that you do have in the question box below or on the right hand side of your screen. So to raise your hand, you can click on the icon or your dashboard below or to the right. Download this presentation and additional resources in the handout box. So please, in the handout box, it's there. You will will also be able to download it from guided learning, from the guided learning platform. So if you will not be able to do it today during the session, you can download it there. So please leave, if you do have any questions or comments, you can send it through to us, academics@impact.co.za. And if there are any other questions and you are not registered with Impact, you can send an email through to info@impact.co.za. And if you do want to listen to the video again, you can go to the Impact YouTube channel for recordings of this session. So what I'm going to cover today is physics as well as chemistry. I wanted to do a few physics, electricity and magnetism, just a bit of revision about the session that I did last, the last webinar that I did. The reason why I want to cover this a bit of revision is because I do have a lot of questions regarding the questions that the handouts and the notes that you received last, so I'm just going to cover that. So I'm going to do electrostatic calculations and electrical circuit calculations. I'm just going to revise series and parallel circuits again, so just to make sure that you do understand that. All right, the first thing is, what is the difference between a series and parallel circuit? Now listen, if we look at the series circuit on the left-hand side, you can see that the circuit, the electrons are flowing from, the electrical energy are flowing from the positive side of the cell through the first light bulb, then the second one, and again through the, can you see there's a switch there, and then to the negative terminal. If we draw it, you can see that we have the cell here with the first bulb, the second bulb, and then the, again, sorry, right, then again to the switch. Now, if we look on the right-hand side, we have the parallel circuit. You can see that from the cell, there's a different way of electron flow. Why? Because there's a split, because the two bulbs are in parallel now. So what will happen with the electrical energy here? The electrical energy will split between the two bulbs, as you can see here, but at the end, they will again reconnect and go through the switch and again to the negative terminal. So if we want to draw the difference between the two of them, you can see that the two bulbs are in series or in parallel. If I'm going back again to where you have the circuit diagram, you can see that here are one bulb, there are two bulbs because it's split there. All right, so now if we look at the difference between the two, the series and the parallel circuits, I just include this again here so that you can see that, remember, the voltage over the cells that you do have there, the voltage over the cells are the total voltage. Please remember that it's the total voltage. So what is happening with the total voltage in a series circuit? It is, you can add them together. So if we look at the total voltage here, you will see that voltmeter 1 and voltmeter 2 will add up. Right, so here, I just want to change this to a laser pen for us to see better. All right, so yeah, now that's better. So here you can see that you're adding the two voltmeter readings together. But in the parallel circuit, even if there are a voltmeter 2 and a voltmeter 1, it's the same. So voltmeter the total voltmeter equals voltmeter reading 1 equals voltmeter reading 2 equals the parallel voltmeter. But remember, if there's in the circuit another volt as well in series, then there will be another voltmeter reading, and then that will you add that then together with the voltmeter reading over the parallel, and that will give you the total voltmeter reading. So what is happening with the electrical energy, right, that you can read through the ammeter, in any case the electrical circuit here, in the electrical circuit. So what will happen with that, if we do the calculation, you will see the ammeter reading A1 will be equal to the ammeter reading A2. But what will happen now with the ammeter reading in the parallel circuit? The moment when it's coming from the positive side and it splits between the two of them, you can see here that both of them will have, if they are the same, if they do have the same resistance, the ammeter readings will be the same. But if the resistance between the two of them are not the same, then it will be according to the ratio of the two of them. Say for example, if the one is 1 ohm and the other one is 2 ohm, then you will have you have a free electrical energy. Then you will see that the ammeter reading 3 and the ammeter reading 4 will be in the same ratio but in the opposite. So say for example 1 and 2, the ratio for this will be 2 to 1. Because of the electrical energy will change between the two of them according to the ratio. The less resistance will have the higher electrical energy and the electrical current, and the higher resistance will have the less electrical current. So if we look then here, we will see you can also not, when you have to calculate the total resistance, you can just add the series resistance together. But in the case of parallel resistance, you have to put it R over RP equals R over R1 plus R 1 over R2. 1 over R1 plus 1 over R2. So please make sure that you do understand that. So now, if we look at, if I'm asking you a question, for example, what is the equivalent resistance of the circuit? Now, what is the meaning of equivalent? Equivalent means that if I add these two together, if I add them together, and I do have only one, that is the equivalent resistance of the two resistors. Okay, so how do we're gonna calculate that? Again, with your formula, from your formula sheet, you can see that the formula from the formula sheet for the parallel circuit is 1 over Rp equals 1 over R1 plus 1 over R2. Adding them together, in this case, you have a 2 and a 4, so make sure that you have the same denominator, and then you will see it is a half. It's also 2 quarters, and 2 quarters plus 1 quarter is 3 quarters. But remember, this is 1 over Rp, not 1 over R. So this is wrong. My apologies for that. I will make sure that I will change that again. That must be 1 over Rp. 1 over Rp equals 1 over 2 plus 1 over 4. So 1 over Rp will be 3 over 4. So Rp will be 4 over 3, and that is 1 over 3. So now we can add together the resistance of R1 plus the parallel resistance, that's 1,33 ohm. So my total resistance will be 5,33 ohm. So the equivalent resistance for the two resistors here will be then 1,33 ohm, and that you add that together for the R total in the circuit. Make sure that you do know the meaning of the equivalent resistance. All right. So now, what is electrostatic calculations? If we look at electrostatic calculations, and we can see that we have a the data sheet for the physical sciences. Now listen, you received during a physical science paper and a chemistry paper, you received data for physical sciences for paper 1 and paper 2. You have physical constants for both physics and chemistry, and you have formulas. All right. Now, what is the physical constant? If we look at this, you can see it's gravity, speed of light in a vacuum, Planck's constant, Coulomb's constant, charge on an electron mass. So what are you going to use is you have to make sure that you do understand what the meaning is of each and every one of these symbols. Why? Because you're going to use it in your formula. Can you see there? You can see a QE. Now, what the heck is QE? It is the charge on an electron. Can you see there's the charge on an electron? So you have to make sure that you do understand what each symbol represents in these formulas in order to do the calculations. All right, so the question that I gave to you last week is the question or the previous handouts or the notes was questions about charges as well as electrical circuits. So now the first one was you do have two identical metal spheres A and B on an isolated surface, carry charges of plus 25 multiplied by 10 to the minus 6 coulomb, and the other one is minus 18 multiplied by 10 to the minus 6 coulomb. So you do have these two spheres, and then you brought them in contact with each other and with one another, and are then allowed to move freely again. So what is happening here? If you assume that the surface is frictionless, what will happen? You can see here you have a plus and a minus. So when they're coming together, you can see that after they connect to each other, after the was in contact, then they just move apart again. So what is happening here? So I want you to understand the type of questions when you receive something like this. What will you observe regarding the motion of the spheres directly after contact? Observe regarding the motion of the spheres. If they do have a different a plus and a minus, positive and negative subtract each other. But after they are in contact, there will be a transfer of electrons, and they will have the same charge after contact. And then they will, because of the fact that they do have the same charge, they will move apart again. So make sure that you do understand that. I will show you now the answers. The next thing is calculate the new charge. So let us just see. Yeah, the spheres move away from each other after contact, because as soon as the spheres touch, electrons flow until both have the same charge, and as soon as the charges are the same, the spheres will repel each other. What do we expect from you? You have to explain. So you have to say that they move away. and you have to give a reason why they move away from each other. All right, now we ask, the question is, calculate the new charge on each sphere after they made contact. Where do I get formula? Can you see? On my formula sheet, there's the formula. Q equals Q1 plus Q2 divided by 2. So you add the charges of the two together. Write the formula as you have it on the formula sheet. You get a mark for that. If you don't have the same formula, you will not receive any marks for that. So first, in some cases, you will see, like for example, you can see here, there's no, you will receive a mark, but I will come to this formula now, back now. So first, not always you will, if you see there's 3 marks, you will remember you will not receive any marks on for the formula, but you must have the correct formula. By using not the correct formula, you will not receive any marks for the calculation. So then you write the two charges of Q1 and Q2 divided by 2, and then you have an answer with the unit. Remember, an answer with the unit. You must have a unit with your answer. So now, in the next question, we ask, calculate the number of electrons transferred during contact. There were 2 different charges, or maybe they're the same, but in this case, there are 2 different charges. Now we want to know what is the number of electrons transferred during contact. All right, how do we do that? Are there any formula for that on your formula sheet? You have 2 formulas here on your formula sheet. Q equals NQ and Q equals Q1 plus Q2. That are the 2 formulas that you do receive on the formula sheet. All right, it is, you make sure now you know that what formula am I going to use? Number of electrons equal the change in the charge divided by the electron. What's electron? The charge on 1 electron. Where do I get these formulas? Where do I get this formula from? This formula is not on your formula sheet. Now you can phone me and say, you know, man, sorry, but you use formulas that's not on my formula sheet. Listen, you do have formulas in your study guides that's not on your formula sheet. So what must you do then? You have to learn that formula. It's not on your formula sheet. So please make sure, go to your test, your previous tests that you received in term 1. Take the formula sheets that you received that were attached at the back of the formulas, at the back of the question paper. Take that formula sheet. Write all the formulas that's on your study guide that's not on the formula sheet. Write it with a red pen and make sure that you learn it. This is a formula that's in your study guide. Number of electrons is the change in charge divided by the charge on 1 electron. So it's the final charge minus the initial charge. So the final charge is the one that you calculated here. What was the initial charge? Take one of them. And so the initial charge on one of them was 18 multiplied by 10 to the minus 6 divided by that, because what was the question? Calculate the number of electrons transferred during contact. During contact. Okay, how many electrons was transferred from this one to that one? All right, so that is why we use the minus 18 multiplied by 10 to the minus 6. That is the new charge. That is what it was. So it changed from that to that. So how many electrons were transferred? So during transfer, that is the number of electrons that is being transferred during contact. All right. And then the last question is, were the electrons transferred from sphere A to sphere B or from sphere B to sphere A? So what uh, could you have to in the next question, in this question? You can also use the other one. You can also use this one and see how many electrons were transferred. So were the electrons transferred from A to B or B to C or B to A? So let us just see B to A, since B has an excess of electrons. So this is something that you must learn and know. Okay, so now the electrical circuit calculation. What was the question that I gave you on that on the notes? If you didn't receive this, or if you didn't download it, make sure that you go onto our guided learning platform and download it. And if you're not an impact learner, you can send through an email to Impact, and they will forward the email to me, or can send through one to Academics at Impact, and then we can make sure that you will receive the notes. Okay, this is the other circuit diagram. The circuit diagram that I gave to you was this one that you can see here. It's the same questions that were on the notes, the previous notes. After the last webinar, there were notes, and that this question was the same. So here you can see it's a different circuit diagram as the one that you saw until now. There's an 8 ohm resistor, and then there's a 6 ohm, and the 8 ohm resistor is in series with the 6 ohm resistor. Another 4 ohm resistor is in series with the 6 ohm resistor, and both of them are in parallel with a different resistor that we don't know the resistance of this one. So the first thing is the reading on the voltmeter. On voltmeter reading 1 is 26 volt, and the current through the ammeter is 2 ampere. Calculate the total resistance of the circuit. So now, how am I going to do that? If I'm not sure. All right, what do I have? 26 volt is the total resistance of voltmeter 1. 2 ampere is the ammeter reading there. So the easiest way is to use Ohm's law, R equals V over I, to calculate R total equals V over I to calculate my total resistance, and that's 13 ohm. Why can't I use the other one? Because I don't have the resistance of this one. So I cannot use any other formula than just use, and that is the easiest way, by using R equals V over I, and that is also a formula that you will receive that's on your formula sheet. So just go and use R equals Ohm's law, R equals V over I, and that is 26 divided by 2, and that is 13 ohm. So now the next one is the next question. The next question is calculate the reading on V3. Now again, V3 is a voltmeter that's just over the 8 ohm resistance. You do have the ammeter reading of the circuit, and you do have the resistance. So the formula you can use is, if you manipulate your formula R equals V over I, then you will see V equals I multiplied by R. So the I is 2 amps and the resistance is 8. So my volts over my volts over the series resistor is therefore 16 volts. 16 of the 26 volt is the voltmeter reading of the 8 ohm resistance. Okay, so now the next question, sorry about that. So the next question again is calculate the magnitude of resistance on now. Now you do have to calculate that. How am I going to do that? If I'm not sure, you know that you have an 8 ohm resistor. If we look at the total resistance you calculate that is 13 ohm. You do have an 8 ohm resistor in series. So the parallel circuit in total do have a resistance of 5 ohm. So if we look at the circuit diagram here, you can see that this resistance is the minus the total resistance will give the total resistance, the RP resistance. So, all right, so let us just then calculate again. We do know that the total parallel circuit resistance is 5 ohm. We do have a 6 ohm and a 4 ohm resistor that is in series, and that gives you the 10 ohm resistance here. So we have a total resistance 1 over 5, 1 over 10, 1 over R. And by doing the maths, you will see that R equals 10 ohm at the end. So now we know that from that R equals, that is from the in my parallel resistor, that one is, that R there is 10 ohms. Remember, it will 1 over 10 plus 1 over 10 will give you in the end 1 over 5. So therefore we see the next question, calculate the reading on V2. So now we want to know the voltmeter reading. We did know at the back, we know that the voltmeter reading over the parallel circuit, the parallel part of the circuit, will be the same. It doesn't matter if it's over the whole one here or the whole one there. So, but here the voltmeter reading is over the 4 ohm resistance and not over the 10 ohm resistance here. So how are you going to calculate that? V2 equals 2 divided by 2 multiplied by 4. Why? Because in that circuit, the I over my 4 ohm resistor, you calculate by 2 divided by 2 multiplied by 4. So it is 4 volts. Okay, now we have the last question is calculate how much charge flows through the 8 ohm resistor in 4.5 minutes. You must remember that 4.5 minutes must be in seconds, so you have to change it to seconds first before you do your calculation. So it's 4.5 multiplied by 60. How do I get to 60? 4.5 minutes, 60 seconds. So that is why it's 4.5. 1 second is 1 minute is 60 seconds. So that's why you have to multiply by 60, multiply by 4.5 in order to get your answer. I hope this helps. So if you so if you still not knowing or still struggle with this, you're more than welcome to send me an email. Now, the other part of the webinar today is chemical change. It's the writing and balancing of chemical equations. But in order to write and balance that, that's the new part of this of your chemistry that we didn't do the last time. But matter and materials revision, you need to remember and understand the chemical formula, how to write a chemical formula in order to write and balance a chemical equation. So I'm not sure if you remember this chemical formula, how to write iron hydroxide. So let us just see, how do I know what is the charge on iron and what is the charge on a hydroxide in order to write my formula, in order to write a chemical equation. Now listen, if you want to complete your grade 10, 11 and 12 chemistry, you need to learn and understand how the periodic table of elements works, as well as the table of positive ions and the table of negative ions. If you don't learn it, you're not going to be able to write formulas, you're not going to be able to write the chemical equations that's necessary this year in grade 11 and in grade 12. So you need to learn, and you need to learn all these symbols, and you need to understand. I did receive an email from a grade 12 learner, and that is a great concern for me. I'm not going to disclose his name, but he doesn't understand the periodic table. He can't remember the names of the different chemicals, and that is a problem when you get to grade 12. So please make sure that you learn and understand what's the periodic table about. It's not necessary for you to learn the periodic table out of your head, because you do receive this in the exam. So this is a tool. You just need to understand and must know how to apply the periodic table and how to why it works, how the periodic is set like it is. So go back to the first part of your chemistry that you did previously in term 1 and 2, in order to apply your knowledge from the periodic table. Just in a 1 or 2 minutes, I just want to explain again. This is the key that you do receive from. This is the periodic table you receive in the exam. So all the elements in group 1, they will have 1 positive charges. Group 2, remember your ionic bonds and your covalent bonds. That information is necessary for you to write the formulas in order to write the chemical equations. So yes, if you do have a periodic table next to you now, just write. Group 1 will have ion charge of 1 positive. Group 2, 2 positive. Group 3, 3 positive. 4, 4 positive. 5, 5. What will happen with its 4 will be either positive, negative, but it bonds covalently, because then it will not have any charge. So in extreme times, it will have a charge of either 4 positive or 4 negative, but most commonly we must just remember that they will share 4 electrons. Okay. They will not give it away. So here we will have 3 negative, 2 negative, and 1 negative. And your noble gases don't have any charge. So let us just look then at my table of positive ions. It is not necessary for you to understand why is it NH4 positive. Because you must know that ammonium is NH4 positive. Right. When you do dative covalent bonds, you will understand why it is NH4 positive, but a lot of the negative ions, it's not necessary for you to explain how it forms like it does. So here you can see hydrogen, potassium, sodium, lithium. All of them are on the periodic table in group 1, hydrogen, lithium, sodium, and potassium. That you can read from the periodic table. It's not necessary to learn that off by heart. But I can assure you, by using that in a lot of equations, when writing equations in chemistry, you will in any case to learn that at the end you can see it. By writing the formulas, it becomes easy all the time. So copper and lead and then it's not lead, it's mercury and silver. If we look at them on the periodic table, where are they on the periodic table? You will see that yes, iron, manganese, chromium, cobalt, nickel, copper, zinc, silver, lead, cadmium, mercury, platinum, all of them gold, all of them that are here and they're part of the transition metals. The transition metals, that's cadmium, that's so all of them, the transition metals, they can have a 1 positive, 2 positive, 3 positive, 4 positive for that. That's why we have iron 3 positive. But you will see that we also have iron 1 and iron 2 positive. So that's why you must make sure that you do understand that your transition metals can have different ion charges. So now you can ask to me, but how are you supposed to know that? If they say iron-free hydroxide, then you know that you use the iron-free, it's the iron-free positive, that the charge on the iron is free positive. Hydroxide, the charge on hydroxide is 1 negative if we look at the ion charge. So please, learners, make sure that you do learn all these radicals, these polyatomic ions. They are radically different than all the others on the periodic table. You can see fluorine, chlorine, bromine, fluorine, chlorine, and bromine, and iodine. All of them, they are in group 7. The moment they do have a charge, they become fluoride. Chlorine becomes fluoride. Bromine, bromide. Iodine, iodide. Sulfur, sulfide. Nitrogen, nitride. Oxygen, oxide. And phosphorus is phosphide. Make sure that you can read from the periodic table in the group they are. Right, here you can see all the different radicals that you're supposed to know. Now listen, MnO4, it's permanganate. That's its name. You cannot change its name. You cannot change the formula. That is permanganate. So that is the formula as you write the formulas as they are on the ion charge table. So what is the chemical formula? It is a shorthand way to use chemical symbols and numbers to represent a substance. How do you write it? Okay? By balancing the charges. By balancing the charges, therefore balancing oxidation numbers that you will learn as well in page 11. So a subscript is a number written below and to the right. That is a subscript. That is a subscript. That is a subscript. The subscript tells you how many atoms are in this molecule. How many carbon atoms are in this molecule? How many hydrogen atoms are in this molecule? How many oxygen atoms are in this molecule? So if there's no subscript, then there is just one atom. So please make sure that you do understand it. Here I include a few chemicals formulas that you can practice to make sure that you do understand that. Calcium is in group 2 on the periodic table, and nitrate is NO3 minus 1. Okay, now how do you balance this? You just balance the superscript becomes the subscript of the one that you need to balance. Can you see? That's why we have the formula Ca, because you get the lowest common denominator. So the lowest common denominator of 2 and 1 is 2. So you need to multiply the minus 1 by 2 in order to equal these two. Calcium is in any case 2, so 2 multiplied by minus 1 will give you minus 2, so then you can balance the two oxidation numbers. Plus 2 minus 2 will give you a neutral formula, calcium nitrate. But remember, can you see here, the nitrate becomes in, you have to write brackets around the nitrate because there are two nitrate formulas that combine with one calcium. All right, you can do the rest yourself, and please, if you do have a question regarding that, you can email me. Now, let us just get to the writing and balancing of chemical equations. How do you write and balance a chemical equation? I hope you're still there. Let me just see. By raising your hands, you can just, oh, thank you, you are there. Thank you very much. Thank you for showing me you're still there. All right, let us just start with the writing and balancing of the chemical equations. All right, you first start with, you will see, you will have a certain scenario, and then you have to write the chemical equation. You will have hydrogen that reacts with oxygen, and that will form water. All right, now hydrogen, you need for one oxygen. How do I know I need 2 hydrogens for 1 oxygen? By looking on the periodic table, you know that hydrogen is in group 2 on the periodic table, in group 1 on the periodic table, and ion charge is 1 positive. Oxygen is in group 6 and needs 2 electrons to have 8 electrons in its outer shell. So that's why it will become a 2 negative. So 2 positives and a 2 negative, and that's why our formula is H2O. All right. What are chemical equations? Chemical equations use chemical formulas and other symbols instead of words to summarize a reaction. So methane reacts with oxygen. It burns with oxygen, and the yield that we do have is carbon dioxide. The products that form is carbon dioxide and water. So you have reactants and you have products on the other side. The reactants are the two on this side. The products are that what forms on the other side. What you start out with is therefore your reactants, and what you end with is your products. All right. Here you can see there's a symbol and there's formulas and there's subscript there. All right. So let us just look at an example. We have here. Now listen, this is always very strange for me, because if we think about table salt, guys, all of us eat table salt on our food. So okay, table salt. The formula for table salt is sodium chloride. That's the formula. Sodium is in group 1 on the periodic table. So sodium's ion charge will therefore be 1 positive. That's a metal. It's a soft metal. You can cut it, guys. And then you have chlorine gas. Now, chlorine gas is a yellow gas, and it's in any case it's a diatomic molecule. So it's around us if you are walking around the swimming pool and your dad just throw in some chlorine, you will immediately smell the gas. So it's a metal and a gas that forms a salt. Something drastic must happen with this metal and this gas in order for me to eat table salt. That's why. I'm not sure about this and that, because this I will not eat. That for sure I will not eat. That is poisonous in any case by inhaling a lot of it. So what will happen with this and that for me to eat table salt on my food? So here we have the sodium solid atom with one electron in its outer shell. That is why it is in group 3 sodium. In group 1, period 3, only one electron in the outer shell. Chlorine is in group 7. Why? Because chlorine does have 7 electrons in its outer shell. All right. So chlorine does need only one electron, and sodium can give away one to have a fully second orbit. Okay, but in order, it is in nature like that. I would rather give away to be perfect than just hold on to what I do have here. So why? Because I want to be the model. I want to be the model, so I will buy it. Yes. So that is happening here. What is happening here? The sodium is then a positive ion, and the chlorine is a negative ion, and positive and negative. Can you see there is the electron from sodium, and now there are sodium and chlorine atoms that can attract each other. Positive and negative attract each other, and we have sodium chloride table salt. Luckily, that sodium chloride form in nature, we have a lot of salt mines. So yes, so what are the reactants here? The reactants were the sodium and the chlorine gas. They are the sodium and chlorine gas, and my product is table salt. So I have sodium. Let us just look again. Sodium and chlorine. That chlorine gas is a diatomic molecule, as I said. A diatomic molecule that bonds covalently with each other. So that's why you need to write the formula. You need to write the formula as a diatomic molecule, and you know the ratio is 1:1. My formula is sodium chloride, so they form two sodium chloride crystals. All right. So what must you do? There are certain steps that you need to follow for balancing chemical equations. Identify the reactants, write a word equation, write the correct formula, indicate the state of each reactant, count the number of atoms, and check the total of number of atoms. All right. I did include here a example for you, so that you can see nitrogen gas reacts with hydrogen gas and form ammonia gas. So we have nitrogen gas that reacts with hydrogen to form ammonia gas. There's the first step, write in word form. Then write the correct formula. You know nitrogen is a diatomic molecule. You know hydrogen is a diatomic molecule. And nitrogen is in group 5 on the periodic table. It needs 3 hydrogens or 3 electrons to have 8 electrons in the outer shell. So therefore it will bond with 3 hydrogens. My formula is NH3. Now you have to balance it. How do you balance it? Write down what you have on the left hand. side and write down what you have on the right-hand side. After you write them, the reactants and the products in formula form, and to indicate the state of each reactant, you write down what you do have on each side and then just balance it. How do I balance it? By writing a 2 in front of it because you need 2 nitrogens, but writing a 2 in front here, you must also write, okay, there are 2, so this is, I must remove this. My apologies, so this is not supposed to be a 2 there, so just consider it's N2 plus 3H2, and that is 2NH3, because you do have 6 hydrogens on this side and 6 hydrogens on that side. All right. Lastly, I include this part each time for the learners that log in for the first time, just to remind all of you about the Doc Scientia tools that you do have, the Quanta books that you do receive this year, with your parcels, with your products, and the science clinics seminars this year. All right, you do have the study guides, Doc Scientia study guides, and if you're not with Impact, you can just send an email to Impact to ask them how you can get hold of them. There are summaries at the end of each unit with mind maps that make it very easy to learn. The question papers I did give to you. That's part of the handouts that you do receive today. And each time when we do have a webinar, then we have the exercise books and the past papers you can order from them. All right, the Quanta books, please learners, make sure that you use your Quanta book DVDs. At the back of the Quanta books, there are DVDs with lessons on it. It's not long DVDs, it's 10-minute lessons explaining the most important and most crucial terms and facts of the physics and chemistry. There's also a formula sheet in the beginning of it, as well as mathematical skills. I just want to make one thing clear. Remember, if you look at the back, the memorandums are at the back of the Quanta book, and make sure that you do understand the multiple choice questions. It's very valuable. The explanations at the back, when she's explaining the multiple choice questions, why is it A, not B, etc. Then we have the science clinic notes and exam seminars. I did talk to James Hayes yesterday. He said to me they're busy rolling out the seminars that they're going to host this year, the rest of the year, and how they're going to do it. It's on their website. Go on their website, look at the different events that are available. You can start registering there, and make sure that you download the science clinic notes for free. It's for free, learners. Please make use of that. It's very valuable notes and summaries with calculations next to it. It makes it a lot easier to work with, because I do know the study guides can be overwhelming, all the work that you need to learn. I just want to encourage you again, make use of summaries, work through the summaries, and do as much as you can, do as much questions as you can from the Quanta textbook. The more you do, the more you practice, the easier it gets. And if there are any questions, you can email me, send an email through to academics@impact, or go on our software chat website and ask your questions. And please make use of your time that you do have during this lockdown. Make use of it. If you do have any questions, send through your questions to academics@impact.co.za, or contact us at impact.co.za. I hope you have a nice day, and I really hope that you benefit from this lesson this webinar lesson today, and have a nice day. Thank you very much.